Okay, so in this video we're going to be taking a look at the start to getting set up with both the selection sort and binary search algorithms by first looking at just the selection sort algorithm. So I've got this, this figure right here that shows an int array with some numbers 3, 1, 4, 2 in that order. So if we start at the very beginning with step 0 being when we first introduce this array to this algorithm, we can then go through each one of these 3 steps to kind of sort this array so that everything is in ascending order. So we want to rearrange it from 3, 1, 4, 2 to 1, 2, 3, 4. So the way that we're going to do that is by looking through the array, and we want to identify the smallest item in a certain portion of the array. So when we first start, we're looking for the smallest item in the entire array, and we want to take that item and we want to move that to position 0. And then we're going to take whatever item is at position 0 and swap it. So in this very first step, we're going to look at the entire array. We see that 1 is the smallest value, so we want to move that to position 0, but we're going to see that 3 is already at position 0, so we need to swap that. So you're going to see the 3 and the 1 swapping places at step 1. Once we've done that, then we're going to look through the remainder of the array, so everything except for position 0, and we're going to look for the smallest item in that portion of the array. And the smallest portion, or the smallest item in that portion of the array, is going to be the value 2. So now we want to go ahead and put this value 2, that should go at position 1 in the array. But again, we see that 3 is already at position 1, so we need to go ahead and swap that. So going into step 2, we're going to swap the 2 and the 3, so that now the 2 is at position 1. So now we see the 1 and the 2, those first 2 items, those have already been sorted, and now we still have the other half to sort. So then we're going to go ahead and look at just those last 2 spaces. We're going to check for the smallest item in those, which is the 3 now, and we're going to go ahead and swap that so that we can put that into position 2. And so going into the last step, step 3, we're going to swap the 3 and the 4, and then we're going to see that the entire array has been sorted. And one of the ways that we know that we've reached the end and that we've sorted the entire array is that if the selection sort is working the way that it's supposed to up to this point, once we get to the very last item in the array, which is this 4, then the entire rest of the array has already been sorted, and that 4 that we see at the very end must be the largest value in it. Alright, so now that we've seen this, now we're going to go ahead and actually implement this. So coming over here, we're going to go ahead and make a new program. Or if you're doing this from an IDE, you'll make a new project. We're going to call this selection sort. Okay, so we'll go ahead and make this a public class selection sort. And then we'll also create our main method with public static void main. We'll have our string array of arguments. And then what we're going to go ahead and do is create our array. So we're going to have some int array. So we'll call this numbers again. And we'll go ahead and use these values here. So we'll use this 3, 1, 4, 2. So 3, 1, 4, 2. Go ahead and save that. And then the next thing we're going to go ahead and do is start setting up all of the additional variables that we're going to need for the actual algorithm itself. So the variables that I'm going to be using here, we're going to include a variable called startScan. We'll then still have our index, and then we're also going to include a min index and a min value. Alright, so these are going to be the 4 int variables that we need for this particular algorithm. And if you want a slightly cleaner way of putting this together, we'll go ahead and just rearrange this like so. And we'll just arrange it like this. Okay. So these are going to be the 4 variables we deal with. So we have our start scan, index, and min value. We'll then go ahead and create 2 separate for loops. So this outer for loop is basically to make sure that we are stepping through a particular portion right here. So for each one of these 4 steps, step 0, step 1, step 2, and step 3, that's basically going to make up the outer for loop. And then within each one of those, we need to look through all of the items of the array, or at least all of the items for a particular portion of the array, to find the smallest value within that portion. And that's also going to require another for loop. So essentially what we're going to do is have an outer for loop for the individual steps, and then an inner for loop to look through the individual items at each step. Okay, so this outer for loop is going to be the one that makes use out of this start scan variable, and then the inner for loop is going to make use out of this index variable. And then min index and min value, the names on these are a little bit more self-explanatory, but essentially min index is to keep track of the position of the smallest value in the array, and then min value is to keep track of what that value actually is. Okay, so we'll go ahead and create our first loop, which is going to be using start scan. So we'll have our start scan right here. We'll initialize that to 0 inside of the for loop. We're then going to check to see that this is less than the length of this array minus 1. And the reason we're going to do that, as I mentioned before, when we get to the very last step, step 3 here, we know that this when we get to this very last position right here, if the rest of the array has already been sorted correctly, based on the way that selection sort is supposed to work, then once we get to this point, then we already know that the entire array has been sorted, so we don't really need to look at that last position. So we're going to do numbers.length minus 1, and then we're going to also make sure that we increment the start scan as we go through this. Okay. So then, getting into the body of this for loop, the first thing we want to go ahead and do is set up our min index and min value. So we're going to go ahead and kind of initialize those, getting into each individual step of the algorithm. So we're going to have our min index. This is going to be equal to our start scan. So it's going to be basically where we want to start from. So at the very beginning, this is going to be equal to 0. So our min index, when we first start out with this algorithm, is going to be 0. Essentially, this is going to be a placeholder. In the majority of cases, this is going to get replaced with some value that's smaller than it. But we need to start off with some initial value. So we're just going to start with the very first value of all the ones that we're going to look through. So we're going to use this. And then the min value is going to be the value at this start scan position inside of the array. So this is going to be equal to numbers at the position of start scan. Okay. So initially, this is going to be the 3 right here. So our min index starts off at 0, and our min value starts off at 3. Okay. And then the next thing is to go ahead and start creating the for loop for each individual step. So this is going to be the inner for loop that allows us to step through each of the items in the array, or whatever portion of the array that we're looking at for all the steps that come after the first one. So we're going to do for index is equal to our start scan plus 1. So we want our index to be the next position over from wherever start scan is. So if our start scan starts at 0, then we want to start observing the items from position 1 and on. On the next iteration of the loop, start scan goes up to 1. We're going to be looking at all the items starting from position 2 and going on, and then so forth and so on. Up to this point right now, some of this is very similar to when we looked at that algorithm for just looking up the smallest value in an array. In this particular case, basically what we're doing is just repeating that process of looking up the smallest value over and over again to constantly be able to swap them around in such a way that we can go ahead and sort the array. So it has a lot in common with that particular algorithm. So then the next thing we're going to do is continue with this until we get to the end of the array. So for this one, we're going to go till we get to numbers.length, and we're going to increment the index each time we go through this. Okay. And then inside of here, what we're going to go ahead and do is just do a little check to see whether or not the value of the value inside of the array at our current position, so the value of numbers at position index, if this is less than our min value, then that tells us we found a new min value. So we want to go ahead and assign min value, or assign numbers index to min value. Okay, so we're just going to take whatever we just had and assign that to min value. In addition to that, we're also going to assign the current index to min index. Okay, and the reason that we need to keep track of this is because once we want to do that swapping, we need to make sure we know what position we're swapping to when we need to, rearrange these two items in the list. Okay, so once we've got that, so that's going to complete this if statement. This is also going to complete this for loop. So by the time we get to the end of this for loop, we've done this some number of times. By the end of it, we found the minimum value within that particular subsection of the array. And then at the very end here, we're going to finish up this particular step. So we're still inside of this outer for loop. And at the very end, what we're going to do is take our numbers array, and we want to specify the min index. And this is going to now be equal to whatever was at the start scan. So this particular line is effectively the part where we're swapping the 3 over to this position right here. Okay. So we're taking the 3 that we found at the beginning at position 0, and we're going to assign that to this position here with numbers min index. And then the other thing we need to do is to then swap this 1 over to position 0. And to do that, well, that 1 is this min value that we got right here. So we're just going to go ahead and take our numbers at the position of start scan. And that's now going to be equal to the min value. Okay. So we'll go ahead and do all of this, and then at the very end, I'll go ahead and print this out. So we'll do another for loop right here. And we're going to go ahead and just say for int index equal to 0, index less than numbers dot length, and then index plus plus. And we just want to go ahead and print out the value at that position. Okay. So in this case, we're just going to have it print out the numbers 1, 2, 3, 4, since that should be the order that it sorted everything into by the end of this algorithm. So we'll come over here and we'll compile it. See if I have any mistakes. Okay, yeah. So, yeah, right here, since I used that, let's give this a different one. We'll call this position, or just pause for short. Okay, so do int pause equals 0, pause less than numbers at length, increment pause, and then we'll go ahead and print out the value at that pause in numbers. So we'll go ahead and compile that again now, and then we'll run it. Perfect. And as we can see now, we've got 1, 2, 3, 4, so we've managed to successfully sort the items inside of this array. Okay. So that'll complete the selection sort algorithm. Going into the next video, we'll take a look at the last of these 3 sort of more complex algorithms, which is going to be the binary search.